Good day. Today we look at Unit AG1 of Module 2 and we will revise analytical geometry in general. The first important formula is the distance formula, where we have two coordinates, and then to determine the distance we draw the square root and find the difference in x values and square it, plus the difference in y values and square it. We must also be able to determine the coordinates of a midpoint, where we add the x values of the two coordinates together and divide it by 2. And we also add the two y coordinates together and divide it by 2 to get the midpoint. Remember, m with an uppercase letter represents the midpoint, whereas m with a lowercase letter represents the gradient. Then to determine the gradient of a straight line, we will take the difference in y values above the fraction line and then divide it by the difference in x values below the fraction line. Then a follow-up on the gradient is to determine the equation of the straight line, where we can use the standard equation of a straight line, y equal to mx plus c, where m represents the gradient and c represents the y-intercept. We can also use this formula to determine the equation of a straight line, once again m being the gradient, which passes through the coordinate x of 1 and y of 1. We can also use this formula, x divided by a plus y divided by b equal to 1, where a is the x-intercept and b is the y-intercept. Then we also had special graphs. If x is equal to a number, then it's a vertical line parallel to the y-axis and the gradient is undefined. If y is equal to a number, we have a horizontal line parallel to the x-axis, and in this case the gradient is 0. Then it's important to know that when we have parallel lines, for example AB parallel to CD, it means that the gradient of AB has to be equal to the gradient of CD. For example, if we have a line y equal to 2x plus 4 parallel to y equal to ax minus 2, and we have to find the value of a, we know since they are parallel they have the same gradient, and therefore a will be equal to 2. For perpendicular lines, we know that the product of the two gradients of the lines has to be equal to minus 1. So if we have y equal to 2x plus 4 perpendicular to y equal to ax minus 2, and we have to find the value of a, we will multiply the two gradients with one another to be equal to minus 1. So we know for the first equation the gradient is 2 multiplied by the gradient of the second equation, which is a. The product has to be equal to minus 1. So to get a, or the second gradient alone, we have to do the opposite and divide by 2 on both sides. So minus 1 is divided by 2, and therefore the second gradient is equal to minus a half. Important to know that if one gradient is given, the other gradient will have the opposite sign. So if we had a positive gradient, the second gradient will be negative. And then the reciprocal of the given gradient is used. So basically, if I have 2 over 1, I toss the fraction to get the reciprocal, which is 1 over 2. So let's look at a few more examples where we have a few sets of equations and we have to find the gradient of the parallel line as well as the gradient of the perpendicular line. If we look at the first equation, we have a gradient 3, so for the parallel line they will have the same gradient, and for a perpendicular line we will use the opposite sign, which then will become a minus, and the inverse of 3 is a third. For the second equation, we have a gradient of minus 2/3. So for the parallel line, it will have the same gradient, but for the perpendicular line, we're going to use the opposite sign, which is now a plus, and we're going to toss the fraction to get the inverse 3 over 2 for the perpendicular line. Then we have y equal to 1x plus 2, so the gradient is 1, and for the parallel line, we will use the same gradient. Then for the perpendicular line, we're going to use the opposite sign, which will now be a minus, and for perpendicular lines, the two gradients multiplied by one another must give us minus 1. So 1 times minus 1 do give us minus 1 for the perpendicular line. Then for the next equation, we first have to write it in standard form. So the plus x will be taken to the other side to become a minus x, and minus 6 taken to the other side becomes a plus 6. To get y alone, each term is divided by 2. So 2y divided by 2 is y, and then minus 1x divided by 2 is minus 1x over 2, and 6 divided by 2 gives me 3. So now we have a gradient, which is minus a half. So for parallel lines, we will use the same gradient, minus a half. For perpendicular lines, we will change the sign from a minus to a positive, and we will toss the fraction now 2 over 1, which is 2 for the perpendicular line. Then collinear points are also very important, and it means if A, B, and C are collinear, that their gradients will be equal to one another. It is also important to know that they share a common point. For example, if I have 3 coordinates and I want to prove that they are collinear, I will say that the gradient of LJ must be equal to the gradient of KL, where they share the common point L. So if I first work out the gradient of LJ, I will take the difference in their y values, minus 1 minus minus 3, over the difference in their x values, 5 minus 6. If I then simplify, a minus times a minus becomes a plus, so I have minus 1 plus 3, which is 2, and below the fraction line, 5 minus 6, which is minus 1, and 2 divided by minus 1 is minus 2. If I then work out the gradient of KL, again, I will take the difference in y values, 5 minus minus 1, where the minus times the minus becomes a plus, so 5 plus 1 is 6 above the line, and then divided by the difference in their x values, 2 minus the 5, which is minus 3 below the fraction line. So 6 divided by minus 3 is minus 2, so they do share the same gradient, and they do have a common point L, and therefore we can conclude that these 3 coordinates are collinear. Then we are also familiar with the inclination of a line. If theta is the angle between the positive x-axis and any line AB, then tan theta is equal to the gradient of that line. If we have a positive gradient, then m is greater than 0 and theta is an acute angle. If we have an obtuse angle, we will have a negative gradient where m is smaller than 0. Very important that we subtract the reference angle from 180 to get an obtuse angle. So let's work through a few examples. Consider the following points on a Cartesian plane, coordinate of P, Q, R, and S. Then determine the value or values of K if T is the midpoint of PR, if we have parallel lines, if we have perpendicular lines, or when P, Q, and R are collinear, and then also where RS is equal to 5 times square root 2. For question A, we are working with the coordinates of P and R, since we want the midpoint of PR, and the midpoint is given to us t, where x is minus 1, y is 3. Since we want to work out the value of k, we will add the two y values together and divide it by 2 and set it equal to the midpoint y value, which in this case is 3. So 2 plus k divided by 2 has to equal 3. Then to get rid of the division by 2, we times by 2 on both sides. So 3 times 2 is 6. Then to get k alone, the 2 must be taken to the other side and therefore subtracted on the left-hand side. So 6 minus 2 gives me k equal to 4. Then question B, where we have parallel lines, it means that the gradient of PQ must equal the gradient of RS. So now for the gradient of PQ, I take the difference in y values, 2 minus 1, over the difference in x values, 1 minus 3. Then I simplify, 2 minus 1 is 1 and 1 minus 3 is minus 2. So the gradient of PQ is minus a half. Then the gradient of RS, I take the difference in the y values, k minus minus 3, which becomes a plus 3, over the difference in x values, minus 3 minus 2, which is minus 5. Now since we know for parallel lines the gradients are equal, we set the two gradients equal to one another. Since we have a fraction equal to a fraction, we may cross multiply, where 1 times minus 5 is minus 5, and minus 2 is then multiplied by the k plus 3 on the other side. Simplifying the bracket, minus 2 times k is minus 2k, minus 2 times 3 is minus 6. Then if the minus 6 is taken to the other side, it becomes a plus 6, and minus 5 plus 6 is 1. To get k alone, I divide by minus 2 on both sides. Minus 2k divided by minus 2 is k, and then 1 is also divided by the minus 2, so k is equal to minus a half. Then for perpendicular lines, we know that the product of the two gradients has to equal minus 1. We already worked out the gradient of PQ, which was minus a half, and the gradient of RS, which was k plus 3 over minus 5. So when we multiply these two gradients with one another, it has to equal minus 1. So 1 times the k plus 3 is k plus 3 at the top, and minus 2 times minus 5 gives me a positive 10 at the bottom of the fraction line. Then to get rid of the division by 10, we have to multiply by 10 on both sides. Then minus 1 times 10 is minus 10 on the right-hand side. To get k alone, we have to take the plus 3 over, which becomes a minus 3. So minus 10 minus 3 gives me k equal to minus 13. Then for example D, we know that collinear lines must have the same gradient and share a certain point. We already worked out the gradient of PQ, which is minus a half. We can then also express the gradient of QR in terms of K and the gradient of PR also in terms of K. So for the gradient of QR, we take the difference in y values, 1 minus K, over the difference in x values, 3 minus minus 3. We then simplify, the minus times the minus becomes a plus, and 3 plus 3 is 6 below the fraction line. So the gradient of QR is 1 minus k over 6. The same for the gradient of PR. We take the difference in y values, 2 minus k, on top of the fraction line, divided by the difference in x values, 1 minus the minus 3, where the minus times the minus becomes a plus, and 1 plus 3 is 4 underneath the fraction line. So the gradient of PR is equal to 2 minus k over 4. I can now solve k with different methods. The first method is the more simpler one, where I take the gradient of QR and set it equal to the gradient of PQ the minus a half. Since I then have a fraction equal to a fraction, I may cross multiply. So 1 times 6 gives me 6, and minus 2 is then multiplied with 1 minus k. If I simplify the bracket, minus 2 times 1 is minus 2, and minus 2 times minus k becomes a positive 2k. The minus 2 taken to the other side becomes a plus 2, so 6 plus 2 is 8. To get k alone, I divide by 2 on both sides. 2k divided by 2 is k, and 8 divided by 2 is 4. So the value of k is equal to 4. If you use the alternative methods, you can set the two fractions equal to one another, again cross multiply and simplify to get k equal to 4. In question E, we are given the length RS equal to 5 times square root 2 and then can determine the values of k. So for the distance formula, we draw up a square root and find the difference in x values, minus 3 minus 2, and square it. And then we add the difference in the y values and also square it, k minus the minus 3, and the answer squared. Then RS is given to us 5 times square root 2, so we can set our root equal to the length of RS. Minus 3 minus 2 is minus 5, and minus 5 squared becomes 25. Then the minus times the minus becomes a plus, and then I have to square my bracket, k being squared, 3 squared is 9, and then for the middle term we have k times 3 times 2, which is 6k. Remember, to get rid of a square root, we can square both sides. So if we square the right hand side, the square and the root cancel out, and then I must also square my left hand side. 5 squared is 25, and a square root 2 squared means the square and the root cancels out, so I'm left with 2. So 25 times 2 is 50 on the left hand side. Then I will set my equation equal to 0 in order to factorize. So the 50 taken to the right hand side becomes minus 50. So 25 plus 9 minus 50 is minus 16. The k squared remained like that, and 6k also remained like that. Now I have a quadratic trinomial which I can factorize, and k times k is k squared. 8 times minus 2 is minus 16, and I check my middle term. 8k minus 2k is 6k in the middle. To solve, each factor is set equal to 0 separately, and we solve the linear equation. So k plus 8 equal to 0 means the plus 8 goes to the other side and becomes a minus 8. And for k minus 2 equal to 0 means that the minus 2 goes to the other side and becomes a positive 2. So the value of k could be equal to minus 8, or k can be equal to 2. Example 2, in the diagram we have A with unknown coordinates, B where x is 2, y is 4, and C where x is 0, y is minus 6, and they are vertices of a triangle ABC. The equation of the straight line AB is given, y equal to minus x plus 8. Question A, we have to determine the length of BC in the simplest third form. Then the coordinates of M, the midpoint of BC, then also the gradient of BC, and then we have to determine theta, the inclination of line BC. Then for question B, determine the equation of the straight line AM, which is perpendicular to BC. And then question C, show that the coordinates of A are given where x is 11 and y is minus 3. For question A1, we determine the distance of BC by taking the difference in x values and squaring it, and then add the difference in y values and also square it. So 2 minus 0 is 2, and 2 squared is 4. Then 4 minus the minus 6, we know a minus times a minus becomes a plus, and 4 plus 6 is 10, so 10 squared is 100. Then when I add the two values, we get 104 underneath the square root, which can be simplified as 2 times square root 26. Then for the second part of question A, we have to determine the midpoint of line BC. So we will add the x values and divide it by 2, and we will also add the y values and divide it by 2. So 2 plus 0 is 2, divided by 2 is 1, and 4 plus minus 6 is minus 2 divided by 2, which is minus 1. So M, the midpoint of BC, is where x is 1, y is minus 1. We can then also determine the gradient of BC by taking the difference in y values for minus 6 divided by the difference in x values, 2 minus 0 below the fraction line. The minus times the minus becomes a plus, and 4 plus 6 is 10, and 2 minus 0 is 2, so 10 divided by 2 gives me a gradient of 5 for BC. Now, knowing the gradient of BC, we can say that tan theta is equal to the gradient of BC, which is 5. To work out the reference angle, we press Shift tan of 5 in the bracket, and that gives us theta equal to 78,69 degrees. Then we have to draw a line perpendicular to BC. So the line AM has to be perpendicular to BC. We already know that the gradient of BC is 5 from our previous calculations, and we know that for perpendicular lines, when we multiply the two gradients, it has to equal minus 1. So 5 times the gradient of the perpendicular line must equal minus 1. Therefore, to get the gradient of AM alone, we divide by 5 on both sides, and then the gradient of AM is equal to minus 1 over 5. Remember, we use the opposite sign, and we can just toss the 5 over 1 to get the gradient of the perpendicular line, 1 over 5. We can now determine the equation of the perpendicular line using the standard form of a straight line, y equal to mx plus c, and substituting the gradient of the perpendicular line with minus 1 over 5. Then we can use the coordinate, the midpoint, which is on that perpendicular line, and substitute x with 1 and y with minus 1 to solve c. If we then simplify, c is equal to minus 4 over 5, so the equation is y equal to minus 1 over 5x minus 4 over 5. If you were asked to write the equation in the form ax plus by plus c equal to 0, where a, b, and c are an element of integers, you would have to get rid of the fractions. The lowest common multiple is 5, so basically each term is multiplied by 5 to get rid of the fractions. So y times 5 is 5y. Minus 1 over 5x times 5 means the 5's will cancel out, and I'm left with minus 1x. And minus 4 over 5 multiplied by 5, the 5's will also cancel out, and we are left with minus 4. Then we still have to set our equation equal to 0, so the minus 1x taken to the left becomes a positive x, and minus 4 taken to the left becomes a plus 4, so my equation will now be 5y plus x plus 4 equal to 0. For question C, we know that the coordinate A is where the line AM and the line AB intersect, so to find the point of intersection, we will solve the equations simultaneously. We do have the equation of line AB, which is y equal to minus x plus 8 given to us, and we also worked out the equation of line AM, the perpendicular line, y equal to minus 1 over 5x minus 4 over 5. So we can now set these two equations equal to one another and solve. To get rid of the division by 5, we use the lowest common multiple, which is 5, and each term is then multiplied by 5. So minus x times 5 is minus 5x, 8 times 5 is 40, minus 1 over 5x multiplied by 5 means the 5's will cancel out and I'm left with minus 1x, and minus 4 over 5 times 5 means the 5's will also cancel out and I'm left with minus 4. Then the variables are taken to one side and the constant value is taken to the other side. So minus x taken to the left becomes a plus x, and minus 5x plus 1x is minus 4x. Then the constant values, the 40 taken to the right hand side becomes minus 40, so minus 4 minus 40 is minus 44. To get x alone, I divide by the minus 4 on both sides, and minus 44 divided by minus 4 gives me the x equal to positive 11. But I also want to work out the y coordinate of that point, and therefore I use my first equation, y equal to minus x plus 8, and I substitute the x with the 11 that I've worked out. So minus 11 plus 8 is minus 3, so the y value at coordinate A is minus 3. So A is where x is 11, y is minus 3. That brings us to example 3, where we are given the sketch with theta, alpha and beta. So now we have to determine the value of each angle. We can work out the gradient of AB by using the coordinates given to us. Coordinate of A where x is 0, y is 6, and the coordinate of B where x is 4, y is 0. So we take the difference in y values, 6 minus 0 on top of the fraction line, over the difference in x values, 0 minus 4 below the fraction line. That gives us 6 over minus 4, and when we divide by 2 at the top and the bottom, we can simplify the gradient of AB being minus 3 over 2. We can then use the inclination angle and say that tan alpha is equal to the gradient of AB minus 3 over 2. So to work out the reference angle, we press Shift tan with the 3 over 2 in the bracket to give us the reference angle of 56,3. Note, we do not enter the minus on the calculator, but we know that tan is negative in the second quadrant to give us an obtuse angle, and therefore the reference angle 56,3 is subtracted from 180 to give us the size of alpha, being 123,7. Then, knowing the coordinates of C and D, C being where x is 0, y is 3, and D where x is minus 3, y is 0, we can also work out the gradient of CD. We take the difference in y values, 3 minus 0, over the difference in x values, 0 minus the minus 3. Minus times a minus becomes a plus, so then we have 3 over 3, which gives me the gradient of CD being equal to 1. Then we can use the inclination angle and say that tan beta is equal to the gradient of CD, which is 1. Then we press Shift tan of 1 in the bracket, and that gives us beta equal to 45 degrees. Then for the solution of C, we know that we have vertical opposite angles, so this angle will also be equal to theta. We already worked out alpha and beta, where alpha is the exterior angle of the triangle, and we know the exterior angle is equal to the opposite interior angles, and therefore theta will be equal to alpha minus beta. So the 123 minus beta, which is 45, gives us the value of theta equal to 78,7 degrees. Then next we will run through the properties of our figures, and it's important to know them off by heart. For a square, we know that all four sides are equal in length. All four angles are right angles. The diagonals bisect each other at 90 degrees, and they are also the same length. Then for a rectangle, the opposite sides are equal in length. All four angles are right angles. The diagonals bisect each other and they are also equal in length. Then the rhombus is a parallelogram with four sides of equal length. The diagonals bisect each other at 90 degrees, but the diagonals are not the same length. Then for the parallelogram, the opposite sides are equal as well as parallel to one another, and the diagonals bisect each other. Then a kite, two adjacent pairs are equal in length. Diagonals intersect at 90 degrees, and the long diagonal bisects the short diagonal. Then the areas of the above figures must also be calculated. The area of the parallelogram or the rhombus is the base times the perpendicular height. Then the area of the kite is half the long diagonal times the short diagonal. Then area of the trapezium, we take half the perpendicular height and multiply it by the addition of the parallel sides. Then in analytical geometry, we are often asked to determine the equations of these type of lines, a median, an altitude, or a perpendicular bisector. It is important that you know what each type of line means. If AM is the median, a median comes from a vertex and goes through the midpoint of one of the sides of the triangle. Then if AD is an altitude, it means an altitude comes from a vertex and is perpendicular to one of the sides of the triangle. Then DE is a perpendicular bisector. It is not necessarily drawn from a vertex. A perpendicular bisector bisects one of the sides of a triangle and it is perpendicular to that side. Let's look at another example. We have a sketch with three given coordinates that are vertices of triangle AGR. Prove that triangle AGR is a right-angled triangle. So therefore, we will work with the gradients of the sides and multiply them with one another to get -1. Then B, find the lengths of AG and GR. Then C, calculate the size of angle A without using a calculator. And then D, find the equation of the perpendicular bisector of GR, the altitude of GS, and then the median of GM. On the sketch, it seems that angle G might equal 90, and therefore we will work out the gradient of AG as well as the gradient of GR to see if the product of the two gradients equal -1. So working out the gradient of AG, we take the difference in y values, 2 minus 4, over the difference in x values, -4 minus 2, to get a third. Then the gradient of GR, we take the difference in y values, 4 minus -2, over the difference in x values, 2 minus 4, to get -3. Now we check if the product of the two gradients are -1. So a third times -3 is indeed equal to -1, and therefore we can conclude that AG is perpendicular to GR, and therefore the triangle is right-angled. For the solution of B, we work out the distance of AG as well as GR. We use our distance formula and we find the difference in x values. minus 4 minus 2 and square it, then add the difference in y values 2 minus 4 and also square it to get the square root of 40, which is equal to 2 times square root 10. The same with GR, we use the distance formula and find the difference in x values, 2 minus 4 and square it, and then add the difference in y values, 4 minus 2, also square the answer, add the two answers together to get the square root of 40, and that is equal to 2 times square root 10. So if the two sides are equal, the triangle is an isosceles triangle. Now, since it's an isosceles triangle, we know that angle A must be equal to angle R, and we also know that angle G is 90 degrees because we calculated that these two sides are perpendicular. This leaves 45 degrees for each of these angles because the interior angles of a triangle add up to 180. Then for question D1, if KL is a perpendicular bisector, it means that K is the midpoint of GR. Therefore, if we want to calculate the midpoint K, we will add the x values together and divide it by 2. So 2 plus 4 is 6 divided by 2, which is 3. As well as the y values, also added together. 4 plus minus 2 is 2 divided by 2, which is 1. So the midpoint K is where x is 3, y is 1. We can also work out the gradient of GR by taking the difference in y values over the difference in x values. So 4 minus 2 over 2 minus 4. The minus times the minus becomes a plus, so 4 plus 2 is 6, and 2 minus 4 is minus 2. So 6 divided by minus 2 is minus 3. Then for a perpendicular line, we know that when we multiply the gradients, it must equal minus 1. So therefore, we will change the sign from a minus to a plus, and we will take the inverse of 3. In other words, we toss the fraction if we have 3 over 1, and it now becomes 1 over 3. Now we can determine the equation of KL using the standard equation of a straight line, y equal to mx plus c, where m is now substituted with the gradient 1 over 3, and then we substitute the midpoint, which is on that perpendicular line, in order to solve c. So x is substituted with 3 and y is substituted with 1, and then a third times 3 is 1. When we take the 1 over, it becomes minus 1, and 1 minus 1 gives us the c value of 0. And therefore the equation is y equal to a third x, and plus 0 doesn't have any meaning, so it's just left out as the c value. Then for D2, GS is perpendicular to AR, so we can first work out the gradient of AR by taking the difference in y values over the difference in x values. So now if we take the difference in y values, we will have 2 minus the minus 2 over the difference in x values, minus 4 minus another 4. At the top, a minus times a minus becomes a plus, so 2 plus 2 is 4. And at the bottom, we have minus 4 minus another 4, which is minus 8. If we then simplify the fraction and divide by 4 at the top and the bottom, we have minus a half as the gradient of AR. If we now want to calculate the gradient of the perpendicular line, we will change the sign from a negative to a positive, and we will toss the fraction, which now becomes 2 over 1, or just 2. Then we use the standard form of the straight line, y equal to mx plus c, and substitute the gradient of the perpendicular line into the equation. Then we can also use point G, which is part of this line, to substitute the x with 2 and the y with 4 in order to solve C. 2 times 2 is 4, and when we subtract it on the left-hand side, 4 minus 4 is 0. And therefore, the equation of the perpendicular line is y equal to minus 2x with no C value. For question D3, M is the midpoint of AR, and therefore we can calculate the coordinate by taking the x values and adding them together and then divided by 2, as well as adding the y values together and divided by 2. So the x values, minus 4 plus 4 divided by 2 is 0, and the y values, 2 plus or minus 2 divided by 2 gives me 0 as well. So the midpoint is on the origin where x is 0, y is 0. We can then also calculate the gradient of GM by taking the difference in y values over the difference in x values. So the difference in y values, 4 minus 0 over the difference in x values, 2 minus 0. Then when we simplify, we have 4 over 2, which is 2. So the gradient of GM is equal to 2. So once again, we use the standard form of the straight line, y equal to mx plus c, and substitute the gradient with the 2. Now we can either use the midpoint M, which is on that line, or the point G, where x is 2 and y is 4, to substitute into the standard equation in order to solve C. So if I use my origin, my midpoint, and substitute x with 0 and y with 0 as well, C is also equal to 0 then. In other words, the equation of that line is y equal to 2x. The same will happen if I substitute with coordinates of G, where x is 2 and y is 4. C will also be 0, and my equation is still y equal to 2x. Now that brings us to the end of this lesson discussion, and you may now continue with the activity. Note that the video will be stopped here, and the follow-up activity with memorandum will be done in the next video.